Welcome back again, Year 9 students. You just keep coming back, and I know why too. It's because maths is amazing. We like to keep calm, and we certainly love maths, so let's get into it. Last class, we looked at dealing with Pythagoras' theorem with a slightly different way of setting it out from what we did in Year 8. And this class, we're going to do the same thing, but this time we're going to be finding one of the shorter sides on the triangle. So here's a right angle triangle. And you'll notice that the hypotenuse, the longer side, is 2.6. We're finding a shorter side. Whenever you're finding a shorter side, you're going to have a minus sign in your formula. So this is the way you would have done this in Year 8. You would have said c squared equals a squared plus b squared. Now, the c is the hypotenuse, so you'd have 2.6 squared equals a squared plus 1 squared, or you could have had 1 squared plus a squared. And then you would have squared 2.6 and squared 1. Then you would have had to have minus 1 to both sides. Then you would have to take the square root of both sides, and you'd find out what a is. In Year 9, I'd like you to set it out a little bit differently. What I'd like you to do is to use this formula here. You don't have to write this formula again. The only bit you have to write is the bit that comes in this green box. So, you'll write a because you're looking for side length a. A equals the square root of 2.6 squared, the hypotenuse squared, minus the shorter side squared. Put that into your calculator and you'll get 2.4, finished. A question like this will be worth 2 marks. 1 mark for this line of working, 1 mark for this line of working. If you want to write the formula, that's fine, but you do not have to. That will be taking time that you don't really need to spend. Now I do need to highlight this. If you accidentally put this into your calculator as 1 squared minus 2.6 squared and got it around the wrong way, your calculator would say math error, because you can't do that. That means there's no answer to it. You've done something wrong here, and what you did wrong was put the numbers in the wrong order, because what happens is if you put that into your calculator, it's negative and you cannot take the square root of a negative number. So let's continue. Example number 2. We want to find, not the hypotenuse, a shorter side on our triangle. So that's how we would have done it back in Year 8. In Year 9, we're going to do it like this. The bit in the green box, it's all you'll need to write. We're looking for side length a. So a equals, the longest side is 17, so the square root of 17 squared minus 15 squared, put that into the calculator, a is equal to 8. That's full working out, that's all we need to show. Example number 3. I'm not going to show the Year 8 way anymore. I'll put the formula there, but you don't need to use the formula. What's in the box here? That's all you need to show. We are finding one of the short lengths. We know the hypotenuse, so it's a equals 40 squared take 29 squared under our square root sign. Put that into your calculator and you get 27.5 millimeters if you round it to 1 decimal place. Now, following on from last lesson, if you wanted the exact answer, you would put 40 squared minus 29 squared into your calculator, and let's change to a pen. 40 squared minus 29 squared actually equals 759. So if this question said find the exact side length, you would have done it like this. You would have said a equals the square root of 40 squared minus 29 squared. A equals the square root of 759, because we figured out that 40 squared takes 29 squared is 759, and you'd leave it like that. Let's continue. We're finding one of the shorter sides. Okay, the hypotenuse is 26 meters. Hang on a second, this is a problem. This side here is in centimeters. So I need to make them both in meters or both in centimeters. I'll make them both in meters because it keeps the numbers smaller. 975 centimeters is the same as 9.75 meters because there's 100 centimeters to a meter. So what do I actually have to show? All I have to show is what's in the box here. K equals the square root of 26 squared minus 9.75 squared. Put that into your calculator, and to one decimal place it's 24.1. So there you have it. That's how you find side lengths on right angle triangles if they are not the hypotenuse. It's time for you to do some questions. I know you're going to enjoy them because after all it's maths, and as I've said before, maths is awesome. Bye for now.